Hi, everyone. Welcome to tonight's version of our FRC workshop series. We have a really interesting one tonight. I love the title. It's called The Wheels on the Robot Go Round and Round. And we're going to be talking about some drive bases, be it the Kitaparts basic drive base or some more advanced ones. We're really happy to be able to welcome a couple of members of the Embers team tonight. They are FRC team 7583. We have Ethan, who is in his third year of FRC, and Michaela, who's in her second year. And they are going to tell us all about drive bases. So I will turn it over to you. Thanks for doing this, and yeah, have fun.
Thank you. So welcome to our presentation. We'll try to go over a fair few different things about drive bases, and hopefully you all can learn something. I'm Ethan, and yeah, like Luann said, it's my third year of FRC. I originally started on team 5985, Project Persepolis, and then last year for Destination Deep Space, we formed a team, and that is Embers Robotics, team 7583. Michaela?
So, hi. So a bit of a disclaimer first is that our main competition experience is only with the Kitaparts drive base. So we are by no means experts in this topic, but we can speak from our experiences. It would also be greatly appreciated if you guys notice a mistake, if you could point that out to us in some way. Yeah, thanks.
Cool. So, actually, this is your slide.
The thing's on the wrong side.
Sorry.
Technical difficulties. So we're just going to be talking about the different options for drive bases you have and anything we would have liked to know when it was our first year, including different options, mistakes we've made, and some tips for efficiently assembling your drive base, as well as the general things you'll need to know to get your drive base moving.
Oops. Cool. So the different types of drive bases. So there would be hundreds of ways that you could categorize these, but we've tried to categorize them down to 3 different types. So those would be tank, swerve, and omni. Now, tank is kind of self-explanatory, but it's named after your basic sort of military tank where you've got each side of your drive base, so your left or your right, and they're individually controlled with multiple wheels or tracks or tread that are connected either by belts or chain, and that powers all wheels to sort of give you a movement where you can turn on the spot by having one side in one direction and the right side and the left side spinning in sort of reverse to spin on the spot. You could have both sides spinning in the same direction, but the right side spinning at a slightly higher speed to make a sort of curve turn to the left. And then you just have straight and backward, like forward and backwards, by just powering each side equally in either direction. Then you have swerve. So swerve is, I like to call it, affectionately named due to the movement it makes as it traverses the field. It has the ability to swerve around obstacles, objects, and even other robots, making it great for defense as well as efficiently scoring game pieces in each year. Now, it consists of a wheel per a module that rotates around the concentric axis, so your basic way that a wheel spins, as well as it steers in the direction that your robot wants to move. So because you need multiple modules to make a swerve drive, each module requires 2 motors, and you can make do with 2. Sometimes you can use 3, and in a lot of cases use 4 in each corner of your robot, and this makes it one of the most expensive types of drive base. Then you have Omni. So Omni has a few categories within it, but we just made it one of its own, and it provides omnidirectional movement by the use of special or unconventional wheels, which you normally wouldn't see on a tank drive or even a swerve drive. So starting off with tank, you have sort of these three main ones. Your kit of parts drive base, which is sort of your flagship tank drive. That has a sort of sheet metal frame with 6 wheels, 3 per side, individually controlled by 2 motors per gearbox, and it just uses high grip wheels, which are basic threaded wheels. It's the default drive base that each team is given at the start of their rookie year and every year forward unless you choose to opt out. Now, then you have the West Coast drive. Now, this uses aluminium or metal extrusion, generally in a rectangle or square shape, and it has cantilevered axles. So this means that the wheels are cantilevered outside of the sort of frame. So you can see here on this picture, this one here. I don't know if you can see my mouse, the bottom right picture. The wheels are the furthermost out sort of thing, giving it a really wide and good sort of wheelbase so that it has less ability to tip. While it's not much wider than a kit of parts drive base, it's just a bit wider, which if you have a tall robot, tipping is not something you want. They can have anywhere between 4, 6, 8, 10, 12 wheels, generally equal wheels per side, and you generally have either 2 or 3 motors per gearbox. They can, it's a fairly, there's COTS option, so commercial off-the-shelf options for these sort of style drive bases, whether it's from Vex Pro or West Coast products in America. But they're fairly expensive, and while you can attempt to make them with a hand drill or a drill press, a CNC mill or router would make them a lot easier and provide you with a lot of abilities. So some teams that I thought you could take a look at, and actually in this picture, the top right one is Team 254. A lot of the name West Coast Drive originates from the West Coast of America, where most of the teams there use this sort of drive base. But you can see 254 in 2019 specifically, although they've used it in numerous years prior to that. 5985 down in Wollongong, they've used that since a West Coast drive from Vex Pro, so using commercial off-the-shelf items since 2018, and even 3132, if I recall correctly, used a West Coast drive last year in 2019. So then finally for the tank class, you have a track drive, which actually resembles a tank the most. Now this uses sort of like a belt with grip on it. Now it's not, I wouldn't call it popular by any means, but it has its benefits. So it can maneuver over more difficult terrain as well as get over large obstacles. But a lot of time they're a fair bit slower than other options. So I found some teams that did use them, and of course they were used in 2016 Stronghold, where you had a lot of obstacles in the middle field. So you had 6083, 4237, and 2370. So now we move to Swerve. Swerve is, I'm going to call it an iconic sort of design. Well, it's not available to every team unless you want to spend a fair bit of money, as to buy a commercial off-the-shelf module will set you back, well, to have 4 of them for each corner for your robot will set you back to around 3,000 AUD, which that's about half of your budget, although the bomb is kind of gone now. But a coaxial, so the 2 types of swerve are coaxial and differential. So coaxial is basically the only sort of type of swerve that you would see used in competition, and a differential is more of a mechanical wonder or engineering marvel than an actual field tested design. Yeah, I still thought to include it, as there's a lot of teams that want to be able to use it but haven't had done enough testing with it. as well as the machining, as well as the manufacturing implications that come with it. So a coaxial swerve has, assuming we have a 4-module swerve, you can also have 3 or 2 or 6, but assuming we have a 4-module, they're all independently rotated on the sort of vertical axis so they can steer. Oh, sorry, the slide's still in tank. Sorry about that. Yes, so coaxial swerve, which you can see in the top right and bottom right picture, all swerve have 2 motors. So the wheel can actually rotate sort of like this way. So if the wheel is spinning around like this, it can also rotate this way to steer in a direction. So I'll just use this. If you wanted to roll this way, it can do that just like any drive base, but it can also rotate the wheel around the vertical axis to rotate this way to move the robot in any direction. So this is incredibly useful, as you can probably see. It can switch directions incredibly fast, but the machining implications and the complications that come with machining the gears and and sourcing the bearings and everything that comes with it makes it expensive, hard to justify in a lot of cases unless it is obviously going to bring a big improvement to the game in that year. And it's also hard to program. So as you can imagine, you have to control sort of 8 motors for your drive base, which is fine by itself, but then you have to add encoders, you have to control them in sync, and it just adds implications. So then you go to differential swerve. Now the best example of differential swerve is this top left picture with the red 3D printed parts. And if anyone understands a differential in a car, it still involves 2 motors, but it involves them spinning in either the opposite direction or the same direction at the same time and at varying speeds. So this provides the ability to create the turning action on the vertical axis to steer the wheel, as well as the rotational powering aspect to direct it. As I said before, it's not field tested to an extent. There have been some cases in FTC where teams have used it, but it's even more complicated to machine, and there aren't any commercial off-the-shelf items, off-the-shelf like products that you can buy. Yeah, I think that's about it as well. We're to Omni. So I classed it as Omni purely just because of omnidirectional movement. But an Omni wheel is not this. An Omni wheel provides omnidirectional movement, but it does not power in an omnidirectional direction. That would be your mechanism wheel. So that's where a mechanism drive comes from. So this provides the ability to move in any direction, similar to a swerve, and in the same way, all 4 wheels need to be individually powered. So the mechanism drive is the one in the top right here, top left, and it's accomplished via the use of mechanism wheels, which, as you can see, the rollers on these are at a 45-degree angle relative to the rotation of the wheel, and this means that it directs the wheel being powered directs in at a 45-degree angle. So by powering them in certain ways, you can move forward, but you can also strafe left to right as well as back and rotate in the spot. So then you have Kiwi. This is in the bottom left, and that involves, in this case, it's 3 wheels, but you could also do 6. You could do 4, but basically you want the wheels to all be an equal angle to each other, and sort of so that when you power 2 of them, they move in a direction, but you can also power all of them at the same time. Once again, each wheel has to be individually powered, so it does mean that you need more motors and motor controllers, but it does provide the ability to strafe and go in all sorts of directions. Then you have H drive. Now, H drive is, I don't want to say popularized by 118, but in the recent years that I've seen, they were the big sort of, we use a H drive in FRC. So this is in the top right, and it's also sort of the case in the bottom right, but they use omni wheels where one of the omni wheels is mounted perpendicular to the main wheels. So this gives it the ability to strafe as well as have a lot of sort of kind of keep pushing power in one direction due to majority of the wheels being facing in that one direction. Now, then you have butterfly. Now, butterfly it has a very useful ability of being able to change the wheels that are contacting the floor or the surface you're driving on. So it does this using, in this case, pneumatics. You could use another form of linear actuator, but pneumatics have been known to be easier because of their speed and the force that they actually apply onto the ground. So you have a sort of rocker almost that rocks around a central axis, like from point A to point B as the cylinder actuates, which brings two different wheels in point A and B, and it changes which one is in contact with the ground. So if you have, let's say, a common sort of high grip wheel or a Coulson on there on one side, and you have an omni wheel or even a mechanism on the other side, this provides the ability to go from a highly maneuverable robot that can strafe around the field to a tank that can sort of push game pieces or other robots around to play defense. So while this might seem great and all, I'll go with that one. It does have added cost and more sort of mechanical parts, whether due to it needing pneumatic cylinders, to an extra pair of wheels in this case, and yeah. You can just tell me. I just got a note. Yeah, this is your slide.
So just a bit of information on the kit of parts drive base. When you first get it, make sure that you're not just pulling the parts out of the box, throwing them around. It's really essential that you check to make sure that every single part is there. And if it's not, letting Andy Mark know that straight away. And if you desperately need the parts, contacting a veteran team near you, they could also help you out by loaning you the parts until you get replacements. So when you first set it up, it will take anywhere between 3 to 5 hours. But generally, as your experience and the amount of times you put it together improves, you'll be able to do it a lot quicker than that. You'll need basic skills using hand tools, but power tools are likely not necessary. And you'll probably need wrenches, sockets, imperial Allen keys, and possibly a hammer. We've had to use a hammer quite a lot of times. And to just get it moving with nothing else, with programming, you really don't need much programming knowledge, just a bit of basic computer knowledge, because FIRST provides a template code to get you started. So any team member who has a decent amount of computer skill will be able to get the robot running in a couple of hours.
One second. Cool. So things we did wrong when building the kit of parts drive base. Now, I'm going to say this, and it's assume it was easy. Now, while it's doesn't take a rocket scientist to construct it, you can't just go into it and be like, oh, it'd be like following the instructions of a Lego set. even a Lego set requires you to think about the order of parts, the order that you place the parts together in. So we find ourselves really good at forgetting nuts, belts, even the motors and the gearboxes when constructing it. And you put a piece together and now you have to get a belt in there, and you can't because it's would have to be sandwiched between these two plates that are now bolted together by 12 bolts that now have to come undone to put a bolt back in. And yeah, it's not always fun. Now, when you first get the parts, as Michaela said, you want to look through them all, but you also want to lay them out in a big space, because this will help you sort of familiarize yourself with the parts that you got in the kit, and it won't ask for a pulley and you'd be like, where's that? Did we get that? And then you have to go searching around for it again. And the pieces aren't toys. A lot of time people will see the wheel in the box and just sort of play with it, and then you'll get to the wheel step and you'll be like, oh, we only have 5 wheels. So just make sure that, everyone knows that this is a learning exercise and not a new toy that we just got. So the mechanical, wait, is this the right slide? Yeah, sorry. Details on the kit parts drive base mechanically wise. So in the kit parts drive base, you get 6-inch wheels. These are high grip wheels as marketed by Andy Mark, and they're great. They do the job. They have a lot of grip actually on the carpet surface, and apart from being white, which is a bit of a color in my opinion, as it dirties pretty easily, they're all right, but they can have a bit of a hard time turning. Now, the gearbox that you get with your kit parts drive base, that's called the Tough Box Mini. So this is a plastic sort of housing gearbox, and it consists of a 2-stage reduction and 2 motors that mount onto it. So the reduction that we got in our kit parts was a 10.7:1, but this can be modified if you have, within reason, it can be modified up or down if you have a speed goal or a sort of strength goal that you're trying to achieve with your drive base. Now the frame is made of sheet metal. The main reason I think this is probably done is ease of manufacturing for Andy Mark, rigidity that it generates, and the construction the ease of construction for the end user, which is us. And you may notice if you've seen the drive base, and you can also see in the picture up top here, that there's a heap of holes in them, and you'll probably use maybe 3, 5. Now, this is there so that you can purchase Andy Mark upgrade kits or even make your own upgrades, so that you don't need to make a completely new frame to change the sort of style of drive base that it is. Now, upgrading the kit parts drive base. Sorry. Now, you may have different wheels. You could make a custom gearbox, or you could even just replace the standard motors which you have on there, generally a sim. You could replace those with Neos or Falcons. And then you could look at the Andy Mark upgrade kits. So the Andy Mark upgrade kits are specific kits that are designed and sold by Andy Mark that work pretty seamlessly with the kit parts frame. And these let you sort of turn it into a mechanism drive, or you could add an omni wheel down the line if you want better turning. They just provide a lot of options, although they might come at a steeper cost than if you were to design something yourself. So when we look at different wheels, you can basically choose any wheel that you could ever find, and as long as you adapt it so that it's possible to use in the drive base, whether that's adapting it to have a pulley attached to it or a 1/2-inch hex shaft, any type of wheel will change the way that your robot actually moves. whether you want it to slide around and drift around the field, or whether you want it to basically stick to the carpet floor and not budge when someone tries to push you. So then you could create a custom gearbox. So the Tough Box Mini is, I'll call it limited. You can certainly get different gear sets and change the reduction, but if you want a different type of motor, or you want to completely change the reduction and make it 50-1, and you just want to be a tank that goes around pushing everyone, or you want to fly around the field really fast, you might have to consider making a custom gearbox. Now there are some commercial off-the-shelf products that have bigger sort of changes, like a bigger range of reductions that you can add, but I haven't seen many in Australia, and even if you were to import them from America, they are limited. So I'll definitely look at the custom gearbox option. I've made a triple sim gearbox that mounts onto the kit parts drive base. Now, all that does, it doesn't change the speed necessarily, but it just adds a bit more torque for some pushing power. Yeah.
So once you've got your drive base assembled, you've got to hang up the programming, then it's kind of up to controlling it. So some of the decisions you're going to have to make is what controller you're going to use. There's quite a few that are compatible, recognized with by the driver's station, but if you find one that's not, you can always write some code to make it work. You'll also have to decide whether you're going to have one driver or two. The benefit of having two is to control more of your subsystems by the driver and not have one person trying to do everything. But it also means that doing a bit more driver's practice is really essential to get those two drivers coordinated. But to get started, all you really need is the drive base, electronics, battery, computer running driver station, and the controllers. So, and those are all included in the rookie kit of parts. So it's really easy to get started. It's just all of the messing around, putting things together that you need to do.
Cool. That's all our slides. If anyone has any questions, thank you for listening, and please ask away.
Hi, that was awesome. We have a few questions that have come in. So the first one was, at what point should a team consider moving on from the kit of parts drive base and build a custom drive base?
I'll try and answer that. So if you're enthusiastic about doing it, I think go for it, assuming that you have first, I would say the funding. If you can't afford to comfortably make a custom drive base, whether that's a West Coast drive or a swerve, and even if you have to stretch yourself thin on, let's say, other subsystems, it's not going to be of great benefit, in my opinion, if you have to substitute your intake just so that you could afford to create this drive base. I think also programming-wise, you need to have someone adept to troubleshoot these custom drive bases. Anytime you go to create sort of a proprietary object, it's not just I can find someone else that's done this and integrate it into my own code. Sometimes you have to understand what you're doing a lot more, I think. And then, yeah, I think I had another point. It just kind of left.
That's okay. If you think of it, you can throw it in the midst of these other questions. The next question that came in is, what would you say are the most important pros and cons of a custom drive base versus an off-the-shelf drive base?
Do you have any input, Michaela, or do you want me to?
I mean, I don't know too much about custom drive bases, but I do think, like in the last question, just the cost of it, like for a more veteran team that does really want that, then it's like a bit of a pro for the different things they can provide. But the biggest thing for the kit of parts drive base is just cost.
I think to add to that, there's also the robustness of the design. If you were to make your own design, it's all up. Like if you were to create a custom drive base, it's all up to you to make it rigid and that it will last through competition. If you bought a commercial off-the-shelf drive base, a lot of the time they'll have done the testing that it will last the season and that you're not going to be left without a drive base in the middle of your quarterfinals because the aluminium wasn't thick enough to withstand it.
Okay. So the next question that came in is, the more advanced drive bases seem to be pretty complicated. Do you know if many teams are using those successfully?
I think the teams that use them successfully have a lot of time on their hands and mentors to help develop them, as well as their training with their drivers and maybe just the time in your off season to prototype with these designs, because that's really what you need. You want to see that it's not going to fail in the season. A lot of the high-end teams they don't jump into something to find that it doesn't work in the build season. It will have been tested in the off season before that, or even like in years of development. And I think it's really useful to use that off-season time to find out what's helpful to you, assuming that you can do that.
Great advice. I just have one more question. We were talking before we got on the call here, and you were talking about some of the really out there drive bases you've seen. And the one example you gave us was Team 148 in 2008, which was the overdrive season. Do you want to talk about that for just a second? Tell us what that was all about.
Yeah, so in overdrive, the field was, I'm going to say, a bit less complicated than what we're used to seeing in the recent years. And it was basically, you would just sort of drive around in this oval and you wanted to knock the balls and hit them over this sort of truss. So 148 basically went, well, we just want to go as fast as possible. And they designed a swerve drive sort of nonagon. So the shape of the drive base was actually a nonagon. And it had 3 swerve modules in a triangle. And I'll see if I can drag this picture on. As you can see, they ran a sort of central module that contained all their motors and their gearing. And then they actually ran a sort of chain link system around all of each wheel, all of the wheels for steering and powering it, that actually is pretty incredible to look at. I'll just see if I can find a picture quickly. Yeah, it might take me a bit long to find a picture, but it just shows you that while we talked about all these specific sort of classes, it's complete. If you have the time to prototype something that you think would work great, the sky's the limit. And it's really shown in some teams that have just gone for it.
Cool. We do have a question that came in on the chat. I love this question. If you could give yourself one piece of advice in your rookie year, what would it be?
Mine was so long ago. Michaela?
Oh God, I'd probably say not even that related to drive bases. Just don't get overwhelmed. Like I do remember putting together even the drive base for the first time. There's so many pieces. We didn't know where the instructions were, and it was chaotic. And there was like 5 of us trying to put it together. But I just think not being overwhelmed, like taking a step back, like organizing everything is so important.
Excellent. I think that's great advice to all of our rookies and actually even for our non-rookies out there. So
Yeah.
I don't think we have any more questions. I want to say thank you again. This was fantastic. I think that a lot of our younger teams will be watching this presentation and they're going to glean so much information from it. So thank you so much. As usual, I want to say thank you to the people working behind the scenes here. We have Ian from IC Robotics who has been helping out, doing a fantastic job as well. So thank you, Ian. Thank you, Ethan. Thank you, Michaela. And I guess we're going to sign off for tonight. So have a good night, everybody.